Okay, so in this set of problems, we are regarding the section 2.3, we are going to end up by taking a look at the domain and the range and how the domain and the range are evolving, are they changing or not, if we are dealing with a vertical shift, horizontal shift, and so, and even a vertical shrink or vertical stretch, horizontal shrink or horizontal stretch. So let's do the problem number 69. On the problem number 69, what do we have? Problem number 69. We are starting from the fact that the function f of x has a domain as -1, 2, and as you can see, based on the fact that we are dealing with bracket, -1 and 2 are part of the included in my domain, and the range is 0, 3, and the range of this function is 0, 3. I know nothing about anything else rather than just the domain and the range for that function. But if I end up to look at the function f of x minus 2, what is going to happen? Well, when I look at the function f of x minus 2, that reminds me that basically this is a function g of x, and this function g of x is equal to f of x minus 2. That reminds me that I'm dealing with a function g of x equal to f of x minus k, and that is a horizontal, actually it's a shift. I'm going to erase that, and it is a shift to the right. So basically, I'm dealing with a function that is now been shifted to the right and has been shifted to the right of 2 units. Shift to the right, and because of -2, I know it has been shifted of 2 units to the right. So does that change my domain? Well, I know that I define my domain between -1 and 2. So x equal -1 and x equal 2 for the function f of x are supposed to be on the domain. But now I'm dealing with a function who has been shifted of 2 units to the right. Therefore, I'm dealing with a new domain, and a new domain for my function f of x minus 2, so for my function g of x, it's going to be -1 plus 2, because I'm moving to the right, so I'm moving 2 units to the right, so -1 moving 1 unit, it will be 0, moving 1 unit will be 1, and 2 moving 2 units to the right will be 1 unit 3, 1 unit 4, and my domain will be 1, 4. My range, on the other hand, do not change at all, because I just move horizontally. I never moved vertically. Therefore, all the value of y are exactly the same, and the range doesn't change. So my range still 0, 3. Okay? Now, if I'm looking at the problem number 70, on the problem 70, we are talking about trying to look at the function, so problem number 70, and now the function g of x is equal to 5 times a function f of x plus 1. So first of all, I'm dealing with two things right here. I'm dealing with a shift to the left, and shift to the left because of the plus 1 right here. So that means I'm dealing with a shift to the left, and the 5 indicate that I'm dealing with a vertical stretch. Okay, and I let you refer to what you are supposed to know, just to make sure we understand each other. F of, let me use the right color. So let me use the green. F of x plus 1 make you think about f of x plus k, and that is what you have learned as a shift to the left because it's a plus. Now, again, the red, it's about vertical stretch because it makes you think about that g of x is equal to cf of x plus 1. Or if I could call f of x plus 1, I'm going to call f of x plus 1 a function h of x. Okay? And when h of x equal f of x plus k, we got a shift to the left. And in that case, g of x equals c time h of x with a c greater than 1. And you know that is a vertical stretch. So when we are having a shift to the left, we are sure that our domain is going to change. So therefore, my domain for f of x plus 1, for g of x, the domain, now let me express the domain. So my domain is going to be the -1 to the left. So -1 minus 1, I'm going to go to a -2, and my range and the other value, which was 2 right here, because I'm moving 1 unit to the left, becomes 1. My range is changing. It's changing why? Because I have a vertical stretch. And all the value, and if I had to define, actually, you know what? I am going to define first the domain and the range of h of x. So let's, first of all, let's work on h of x equal f of x plus 1. And I said that the domain is a change into a -2, 1. Okay? And my range, on the other end, for this function f of x plus 1 doesn't change. So technically, my range is 0, 3. But now, if I want to study the function g of x, and g of x is 5 times h of x, that is a vertical stretch. And when I'm vertically stretching a function, I do not change the domain. All the value of x are exactly the same. The only things that are changing is the value of y. Therefore, only the range is going to change. So in that case, the domain of this function g of x, which is 5 times f of x plus 1, is going to have as a domain -2, 1. But for the range, all the value of y are going to be multiplied by 5. Therefore, the 0 multiplied by 5 is going to be 0. Good. But the 3 multiplied by 5 is going to be 15. All right. And it's a bracket. So let me write a bracket. Okay? All right. So now I want to do the problem number 75, because the problem number 75 is dealing with a vertical shrink. So problem number 75. On the problem number 75, we are having a function g of x, and this function g of x is 3 times the function 1/4 over x. 1/4 over x. So what we are able to say is that if I'm calling the function h of x equal f of 1/4 of x, I can clearly now realize that h of x is equal to a function of c of x with c less than 1, and that means it's an horizontal stretch. So in order to understand much better what is going on for the domain and the range, what I'm going to do is I am going to graph. So guys, I'm going to, what I did is I tried to take a function f of x equal x, and then try to define a second function, h of x equal f of 2x, which I know because c is greater than 2, being a horizontal shrink, or c is greater than 1, so being an horizontal shrink, and c of x, another function, this time equal to f of 1/2 of x, and it's going to be a horizontal stretch because c is less than 1. So when I am graphing this function, I can notice that h of x, f of x, and c of x correspond to an horizontal stretch or an horizontal shrink. Why do we say it's an horizontal stretch when we are graphing c of x equal f of 1/2 of x? Of 1/2 x. It is because if I take the coordinate of the point on my function f of x equal x, this one right here, and I look at what should be the new value of x to have exactly the same value of y, and I can see that this value of x has been multiplied by 2. So when you have a 1/2x, you will basically multiply every single value of x by 2. In that case, when I look at the domain of my red function, if I look at the domain of my red function, it is negative infinity plus infinity. There is an infinity of points defining that line. So, thinking that when I look at the domain of my orange function, I basically need to multiply by 2 every single value of x, and because there is an infinity value, obviously it's going to be negative infinity plus infinity. No matter how much I multiply, the domain doesn't change for this function. Okay? If I look also for h of x, the domain for this one is going to be also negative infinity plus infinity. I just need to divide by 2 every single value of x. There is an infinity value of x, so the domain for the function h of x is still negative infinity plus infinity. Now, if I go back to my function from the beginning, which is h of x equal 1/4 over x. Now I know that the domain of this function h of x, it's going to be the domain of my function f of 1/4 over x it's going to be the domain of my function f of x multiplied by 4. The domain of my function f of x, let me get back to the problem, is -1, 2. So, -1 multiplied by 4 is going to be -4. 2 multiplied by 4 is going to be 8. Because I am dealing with a g of x equal 3 times f of 1/4 over x, basically what I have for this one is g of x, let me rewrite this, we're dealing with g of x equal 3 times h of x. That is a vertical stretch. And when I'm vertically stretching, when I'm having a vertical stretch, my domain doesn't change. The value of x are exactly the same. Therefore, the domain of g of x is going to be -4, 8. Now, in terms of range, the range of my function h of x doesn't change, because when you are having an horizontal stretch or shrink, by the way, the domains change, the range doesn't change. But when you're having a vertical stretch or vertical shrink, this is when the range is going to change. And in that case, the range is going to be multiplied by 3 because of the value of c, which is 3 times h of x. And so this is why the range is going to be 0, 9. 0 multiplied by 3, 0. 3 multiplied by 3, 9.